Hey all dear friends, this is Pradesh Chaudhary Quantum Guru. Let's see this very beautiful question of current electricity. Question states a cable AB of length L of uniform wire develops a leak at a certain point. To locate the fault, two observations are made. The resistance between A and the earth through the cable, and when B's earth is found to be that of length L1 of the wire, and that between B and the earth when A's earth is that of a length L2. Find the ratio in which the point at which the fault exists divide AB, and leak is an extra wire having some resistance which gets connected between some point of AB cable and earth. So AB is a uniform wire. This is let me draw wire AB. Uniform cable AB. When I say uniform, it means it's a resistance per unit length the same. So let's assume that it's a R is the resistance per unit length. A fault develops at some point. Suppose here a fault develops. Fault is a resistance from that point to the ground. So there is some resistance from this point to the ground. Ground is written like this symbol. We have to tell at what ratio this fault point divide the wire AB. So we have to find basically what is the AP by PB. Let me assume that the required ratio is mu. AP plus PB, that is the total length of the wire, is L. So AP, length AP, let me assume to be length AP is say A. So that will be, it's dividing the ratio mu to 1. So AP is equal to mu upon mu plus 1 into L. And BP is equal to, say B. BP or PB, and that would be 1 upon mu plus 1 into L. So here this length is A, this length is B, and this leak wire has some resistance, so that is a fixed resistance, assuming that of the made of the same wire of the same resistance per unit length, small r. Suppose its length is say C. So the resistances of these wires, this resistance, this resistance, and this resistance, this would be RA, that would be RB, and that would be RC. Now to locate the fault line, B is grounded, B is grounded, and the resistance between A and the ground is that of the length L1 of the wire. So here you can see that this RB and RC are in parallel, that in turn is in series with RA, and that whole combination is has a equivalent resistance that of the length L1, and that resistance is RL1. So now the equivalent resistance between A and ground is equal to RA plus parallel of RB and RC, that is a 1 by 1 upon RA plus 1 upon RB, and that is equivalent to length L1 of the resistance, so that is a RL1. So if I simplify this, I will get A plus this is RB plus RC, 1 by RB plus 1 by RC. So A plus 1 upon 1 by B plus 1 upon 1 by C is equal to L1. That is my first equation. And similarly, in case 2 now, A is grounded, A is grounded, and the equivalent resistance between B and ground is equal to that of the length L2 of the same wire. So now here you can see that this RA and RC are in parallel, and that is in turn in series with RB, and the whole combination is equal to the resistance of the length L2, that is the RL2. So right now I can write RB plus parallel combination of RA and RC, there is a 1 upon RA plus 1 upon RC, that is equal to RL2. So B plus 1 upon 1 by A plus 1 by C is equal to L2. So this is what we obtained from previous place. Let me rearrange this. So rearranging this, I will get 1 upon 1 by B plus 1 by C is equal to L1 minus A. So again rearranging, I will get 1 by B, just make a reciprocal of both. So 1 by B plus 1 by C is equal to 1 upon L1 minus A. Similarly for this equation, I am using directly 1 by A plus 1 by C is equal to 1 upon L2 minus P. C is the resistance per unit length of the leak wire, and that is what we want to get rid of. So just let me make a difference of these two equations. So 1 by B minus 1 by A will be 1 upon L1 minus A minus 1 upon L2 minus P. And now just again rearranging things. So now what I want to write, 1 by B, let me take this to this side, 1 by B plus 1 by L2 minus P is equal to 1 by A plus 1 upon L1 minus A. Take a LCM. B into L2 minus P, and the numerator I will get L2. And here take a LCM of A, L1 minus A, in the numerator I will get only L1. Let's go to the next page. So this is what we obtained, relationship between L1, L2, A and B. Now put the value of A and B. A is mu L upon mu plus 1 and B is L upon mu plus 1. Some rearrangements. Now some terms will get cancelled. This and this. Want to do now the cross multiplication, this L2 with this and L1 with this. Now take from here a mu square term common. I think there was one more mu square term. There's mu here and this was mu square L. Alright. So if I take mu square term common, L2 L1 minus L2 L, and one term will be mu L1 L2, and here it is a mu L1 L2. From these two I can take a L1 common. So L1 common, that is a L2 minus L. Now from both sides, mu L1 L2 will get cancelled, and here I can take a L1 common, sorry, L2 common. So finally I will get mu square is equal to L1 by L2, L2 minus L upon L1 minus L, and I can also write it square root mu is equal to square root of L1 by L2, and this I can write L minus L2 upon L minus L1, and that is our answer. Thank you.